All right, here we go. All right, one slide. The last slide, guys, we'll do the last slide honestly in about 2 to 3 minutes. It's so quick. And it's so easy. Okay? The hard one is this one. Not that one. This one. This is gonna take some thinking now, okay? All right, but before I do this slide, can I ask you this? Okay? First of all, what is this? Ellipse. In your own words, don't give me the mathematical mumbo jumbo stuff. Just tell me in your own words, what is the definition of an ellipse? It's an oval, okay? But that's not, what I'd like you to do is tell me what the book says an ellipse is in your words. I'll give you a hint. Pick any point on the ellipse. Pick any point, X, Y, and do something with it.
Isn't all these points on the graph connected together?
All these points connected together form an ellipse. That's true, but that's not the mathematical definition. I don't want you to give me all the mathy talk. Just give it to me in your own words. Okay, it has something to do with this. Foci, foci. Yeah, keep going. What about D1? What about D2?
Ellipse is D1 plus D2.
So Corey says, take the two distances, D1 plus D2, and what he means is that distance from that point to that foci, call it D1. That distance from there to there, call that D2. Corey says, add them up, and get what, Corey? He says 2A. What's A? What does A stand for?
Major axis.
Oh, yeah, okay. 2A is the major axis. Olivia, she's right. It is the major axis. This is the answer every time. I was hoping you'd tell me A is from where? Center to where? Vertex. So I was kind of hoping you'd tell me A is center to vertex. Did you tell me that? Maddie, did you say that?
No.
Oh. A is this distance, but the answer is 2A, so it has to be from here to here also. Okay, so basically when you add the two distances, you get 2A. We talked about this, right? Okay, now, tell me, now you guys, I'm only talking about this for a reason, because the story problem, you have to understand it in the story problem. So now tell me this. Here's a hyperbola. Okay, the foci is found here, the foci is found here. Pick any point on the hyperbola, any point. Call it, let's go this one, X, Y. Tell me something about this one. In your own words, it doesn't have to be picture perfect. Ivy?
Distance from the xy to the foci is when you add it up is the same as the center to the vertex or between the vertices.
Okay, you said this distance from here to here, from point to the foci, call that D2. What did you want me to do with those two distances?
Oh, subtract them.
There you go, it's subtraction. So you take the longer number, D2, you subtract the shorter number, D1, and you get some fixed number. But you and I haven't talked about this. What's the fixed number? Is it 2A again? So did we talk about this?
Yeah, we did yesterday.
Did we really? Did we? Oh, I don't remember doing it. Okay. Okay, so you're telling me, and by the way, 2A would be, this is A, right? So from here to here is what? 2A. Okay? So The fixed number is not so fixed. We know what it is. It's 2a. Are you okay with that? Now, do I need to prove it to you, or I can't remember. Did we prove this? I don't think we proved it, did we? I don't think we did. Can I just do this? Can I prove it to you why it's 2a? See this point, x, y? Let's not pick this point. Let's pick that point right there, okay? Now, this is getting really messy, so I have to kind of clean this up just slightly, okay? Okay, here we go. I want this point. Here's your foci. Okay, would you tell me if I pick this point and call this distance 1 and call this distance 2? Okay, now help me. How long is D2? How long is D2 from here to here? Does anybody know how long that is?
2a plus d1.
You're saying 2a plus d1. Okay, don't use a, or don't use d's. Don't use d's. Only use a's and c's. Now, what I mean by that is, isn't this how far? Isn't that a? Isn't this c?
A plus C.
Okay, so you're saying this is a plus c, that would be this distance. A plus c is d2. Everybody good? Okay, what's d1 from here to here? How far is that? Use a's and c's. C minus a. Is he right? Is this distance c minus a? How far is it from here to here? Isn't that c? And what if I shave off this much? Isn't that a? So minus d1, c minus a. Now if I did the mathematics behind this, what's a plus c minus a? Well, this distributes and makes what? Minus c plus a, and then you got an a plus c here. What happens? Boom, boom. The answer is what? 2a. So Corey, I think you said it was 2a, didn't you? Yeah, it's 2a. So I tried to prove it to you why it's 2a. Maybe yesterday I just told you. Did I just tell you?
You kind of proved it yesterday, but it was a different way.
Okay. So now I've kind of proved it. Now I've really proved it. Do you agree it's 2a? Is everybody okay? You have to know this, because if you don't know this, you can't do the story problem. Yeah.
The a plus c minus a. Is that something we need to know?
Not necessarily. No. You know, Hannah, I'm just trying to prove something to you why it's 2a. All the A's and the C's, do you know what A stands for?
Yes.
Are you sure? You've been gone. A is distance from where to where?
The center to the vertex.
Center to the vertex. C is what?
The center to the foci.
Foci, yep. You got it. Okay. Do you need to know what I just did? Do you have to prove it to me? No. I'm proving it to you, so you believe me. Okay? Okay. Now that you know what you know, let's do it. Okay, here it goes. You guys, you got to read a story problem, and you got to read it slowly. Slowly. Okay? Here we go. 2 listening stations, 600 yards apart, hear an explosion. Okay, think about what was said. There's an explosion, and there's a hearing station here, and a hearing station here. They hear the explosion. Okay, how far apart are they? 600 yards. Okay, so can I just do this? Here's A, here's B. What's the distance between them? So from here to here is 600 yards, right? Okay, who hears the explosion? Oh, I haven't read that yet, sorry. Station A hears the sound 1 second before station B. So the explosion is closer to who? Station A. Because they heard it what? Sooner. How much sooner? 1 second sooner. Now everybody knows, sound travels at a certain speed, so the closer you are to the explosion, the quicker you're going to hear it. You ever been in a track meet? Okay, you guys, you know what a 200 meter dash is or a 200 meter sprint? Okay, the guy that goes, ready, set, and he shoots his gun, and if you're on the other side of the track, about 200-300 meters away, you see the smoke. Do you hear it? No, you see the smoke come out of the gun, and then all of a sudden you hear the gun. It's weird. It's like smoke, boom, because it takes time to get from there to your ears. That's why. Now, assume that sound travels at what speed? 1,100 feet per second. You got to assume that, all right? Now, here's what it says. Why do all the possible explosion locations lie on a hyperbolic curve? Okay, watch. Watch this. Ready? Here it comes. Here it comes. Why do the explosions? Look, right here. That could have been the explosion site. Or it could be here. Here. It could be anywhere on the hyperbola. But why? Why? Okay. Because if I take the explosion, all the distance from the explosion to the foci, the distance from the explosion to the next foci, D2, D1, I don't care where it is on this hyperbola. What will the answer be every time? You said 2A, you're right. But I was thinking you were going to say it will always be 1 second. Right? It's always going to be, I don't care where the explosion happened, it's always going to be 1 second. This minus this is always going to be 1 second because they told us station A hears it 1 second before station B. So wherever it is on here, it's always 1 second closer. Now what's 1 second equal to, guys?
1,100.
Yeah, so when I kept saying 1 second to you, you should be saying, no, it's not 1 second closer, it's what? 1,100 feet closer. Do you get that? Okay, hang on. Let me go like this. So D2 minus D1 equals some fixed number. Now, somebody said it right away. What's that fixed number? 2A. You're right, it is 2A. You guys, you're right. It's always going to be 2A. But tell me, that number 2A, they described it as 1 second sooner. They hear it sooner by 1 second. But what's 1 second when it comes to feet? How many feet can sound travel in 1 second?
1,100.
Yeah, so you just do this, don't you? You take 1,100 feet per second, you knock out the seconds, and the answer is 1,100. So this number, 2A, what does 2A actually equal? 2A actually equals 1,100 feet. Okay. So if you know 2A is 1,100 feet, I bet you know A. Say again? 550. So guys, remember when you start a problem in these conic sections, you gotta know A, you gotta know B, you gotta know C. Well, I know A. A is 550. Okay. So do I know anything else? Do I know B? Do I know C? What's C? Okay. Colton says 300 yards. Okay, hang on. Okay, I'm going back up. So here's the deal. I would, if I were you, if I do these problems, I would put the center of my hyperbola at 0, 0. This is where I would always put the center. Okay, Colton says from here to here is 300 yards. He is correct because they're 600 yards apart.
900.
Yeah, but there's a problem here, isn't there? The problem is your A value is in feet and your C value is in yards. Convert it. So we're not going to say this, are we? Aren't we going back to feet? Feet would be easier, wouldn't it? So let's convert to what? Each yard has 3 feet. There it is. It's 900 comma 0, not 300 comma 0. So what's the C value? What's C? From center to foci, 900 feet, right? Good? Now, remember this problem. Hang on, I gotta go back up. I didn't read that last part to you. Here's what they want. Find the equation describing the possible locations of the explosion. The explosion happened on this branch, the right branch, somewhere on here. Well, give me the equation that would give me any point on the hyperbola. So let's go write the equation. The transverse axis was what? Do I need to go back up there and show you? Transverse axis was what? Horizontal. What comes first if it's horizontal? X comes first, Y comes second. The center of the hyperbola was 0, 0. You don't have to worry about anything. Just go x squared, y squared. Okay, what do I put under the x squared? A squared. A is 550? Oh, well that's just 550 squared, right? What do I put under y squared? B squared. Where's B? Oh, I don't have B. Uh-oh. If I don't have B, I gotta go find B. So let's go over here. Remember how to do this? It's just the old Pythagorean theorem. C squared equals A squared plus B squared. So C squared is 900 squared equals 550 squared plus B squared. So B squared equals 900 squared. Take away 550 squared. So B squared equals I know you think I can do all that in my head, but I can't. Just tell me. 500? Okay, there it is. That's B squared. So if that's B squared, I'll stick it right here, and I'll call it good. You can square this if you want, get a big number, I don't care. You can leave this alone if you want, I don't care. But that is the equation that would represent what? What does it represent? It represents what in the story?
Possible locations.
Okay, what?
The possible locations.
Okay, so the possible locations of the explosions. Okay, you know what I'm going to say? On my graph, it would be on the what side? The right branch of the hyperbola. The way I drew it, it was over here, wasn't it? On the right side. That's going to tell you where it could be. Now, can I pinpoint this thing? No, I can't pinpoint it. All I know is it falls on the right branch. Okay? Can I tell you what they're going to do to you? They're going to do this to you. Okay, they're going to say this. What if I told you, I know the explosion happened 1,500 feet east of the center. Okay, here's the center. Where's east? Go to the right. How far? I said 1,500 feet, didn't I? Okay, so if I know it happens 1,500 east of the center, how far north or south could it have happened? Well, then you just go, it happened here, it happened here, but how do you get here and here? What are you going to have to do with this number? Plug it in where? Plug it into, yeah, it's right there. Plug it in for X, solve it for Y. That's what you're going to have to do on your assignment. I don't want to do that. If you okay? If I don't do that? You can do that. All right. That slide took a long time. I had to take a long time because I have to make sure you get that. Okay? It's on your worksheet, tomorrow's worksheet. It's on today's assignment, okay? All right. This slide, this is easy. The only reason you're going to get this wrong on a test is because you didn't do your homework. In today's homework, I believe I added these problems, I think, didn't I? Isn't that what I added? Did I give you evens, odds? What did I give you? Evens. Okay. I'll give you the answers tomorrow. This is so easy. All right, you see this? 1, 2, 3, 4. I added this one this morning. This one's new. Okay, here's the deal. I need you to tell me just by looking at the equation. Is it a circle, parabola, ellipse, hyperbola? Just by looking at the equation. Well, it says identify a conic by its equation. See page 757. I'll just do it for you. If you want to go to page 757 and read about it, this is what it says. If you have an equation where you have x squareds and y squareds, okay, ax squared plus cy squared plus dx e y and f equals 0. So basically, if you have an equation that's in this form right here, which what I'm saying is 0 on one side, everything else on the other side. If you want to know what this thing does, all you got to do is take the a value, take the c value, and do something with it. And by the way, a is found where? Where do you find it? Where's a going to be located?
In front of x squared.
Yep. Where's c going to be located? And the rest of this junk back here, you don't even care. You don't care about that junk. You care about a and c. So here's the deal. If you take a times c and you get 0, something happens. If you take a times c and you get a positive, something happens. A times c, you get a negative, something happens. When you get a times c to be 0, what are you looking for? What is that equation? A circle. No, it's not a circle.
Parabola.
It is a parabola, yes. How about this one? A times c, you get a positive number. That's a circle? Starts with an E. That is an ellipse. If you get a negative number, not many left.
Hyperbola.
That one's the hyperbola. So where's the circle? It's when A and C are the same number. So if A is 4 and C is 4, you have a circle. That's all they're going to tell you there. So this is the circle. Okay, now let's do them. Ready? It doesn't take long to do these. Ready? Where's A? Look at this one.
1.
A is 1. C,
-3.
-3. If you multiply them, you get -3. What is it? This is a hyperbola. Okay, what's this one? A is what? 1. C is what? 1, what is it? Circle. If A and C are the same, it's a circle. Okay, A is what here? 2. C is what? -5. Multiply, you get -10. What is it? Oh, did I do something wrong?
Yeah.
I did something wrong. Sorry. A is 2. Where's the y squared? There is no y squared.
Would be a 0.
So then C is 0. So multiply them, you get what? 0. 0 means what? Parabola. Okay, and then finally this last one is A is 1, C is what? C is 9. Multiply. 9, it's what? This one's an ellipse, right? See what I'm saying? This is easy. This is the last part of your assignment. Matter of fact, this is the majority of your assignment. Okay, now, ready? Listen closely. Your assignment says to do these two. I told you to skip those yesterday, right? Okay. Do that one, for sure. That one, Gabby will be looking for that one, that's bonus. Okay? I did this one. This one is challenging. This one tells you if you really do get it, guys. This is a dandy. You can do it though. I know you guys can do this. Okay, so I'm going to replace 54 with 52. So that the assignment is 52, 55, and what did we say? Did we say this?
Yeah.
Okay, there you go. 54 is bonus. Okay. Okay, that's it. You know what I would like you to do now? Would you go do this right now? Do it. I'll start it in 3 minutes. You guys go do 52.